Bismillahirrahmanirrahim. In the name of Allah, who is the most merciful, the most beneficent. Hope so you all are fine. Myself Ariba Imran and my resource person is Dr. Hamad Majid. Today I am presenting the topic arsenic, that is the metal. Let's have a look on table of contents. First of all, we'll discuss its introduction, then its history, its discovery, occurrence, properties, atomic number, atomic mass, its density. Then we will go its melting point, boiling point, electronic configuration, its analytical chemistry, its reactions, commercial production, pros and cons, biological and physiological significance. Then we will talk to its applications or its usage and how to use, its side effects, environmental impacts, its preventions, remedy, limits, actions against high limits, and lastly, its conclusion. First of all, we'll discuss its introduction, that what is arsenic. Arsenic is basically a naturally occurring chemical element that is widely distributed on Earth's crust with the symbol As and atomic number 33, as you can see in the picture. It is generally considered a metal. Arsenic occurs in many minerals, usually in combination with sulfur and metals, but also as a pure elemental crystal. Arsenic is a metallite. It has various allotropes, but only the grey form, which has a metallic appearance, which is important to industry. Arsenic levels in the environment can vary by locality, and it is found in water, air, and soil. Here is a 3D picture of arsenic. You can easily see. Let's talk about its history. The word arsenic has its origin in the Syriac word zarnika, from Arabic al-zarnik, the orpiment based on Persian zar, gold, from the word meaning yellow, literally gold colored, and hence yellow orpiment. Latin speakers adopt the Greek term as arsenicum, which in French ultimately became arsenic, hence the English word arsenic. Here is a picture in which 3 types of arsenic. You can see first arsenic As2S3, and secondly As2S2, and third is arsenopyrite FeAsS. Let's talk about arsenic, that is a poison, which is famous in history. As the symptoms of arsenic poison are not very specific, the substance was frequently used for murder until the advent in the 1830s of the marsh test, a sensitive chemical for its presence. Owing to its use by the ruling class to murder one another and its potency and discreetness, arsenic has been called the king of poisons because it has certain chemicals and substances that make it a poison. Arsenic became known as the inheritance powder due to its use in killing family members in the Renaissance era. Let's go to its discovery. German alchemist Albertus Magnus, through arsenic compounds, were mined by the early Greek, Chinese, and Egyptian civilizations. It is believed that the element itself was first identified by Magnus, who stated that it has a metal-like nature. Its discovery year is 1783. In the book De Mineribus, he described how the metallite could be produced by heating orpiment As2S3 with soap. Let's talk about its occurrence. Arsenic occurs in large quantities in the Earth's crust. It is present in a number of minerals and occurs in trace quantities in rocks, soil, air, and water. Around a third of atmospheric arsenic is derived from natural sources, for example volcanoes, and the remaining 2/3 occur through man-made sources. High levels of arsenic can be found in drinking water, which have been collected from deeply drilled wells, or indeed as a natural phenomena where groundwater has been contaminated by minerals dissolving from rocks and soils. This problem is more commonplace in South Asia. When we discussing arsenic, there is a question arise in our mind that where is arsenic found? So let's discuss it. First of all, we'll discuss where is arsenic found in nature. Arsenic is released into the air by volcanoes through weathering of arsenic containing minerals and ores, and by commercial or industrial processes. Arsenic enters the environment naturally through groundwater, mineral ore, and geothermal processes. Inorganic arsenic is found in industry, in copper chromated arsenate treated lumber, and in private well water in some parts of the country. Organic arsenic is found in many foods, particularly in shellfish. The organic forms and amounts of arsenic found in seafood are generally considered to be non toxic. Arsenic may be found in foods, seafood, especially bivalves, clams, oysters, scallops, mussels, crustaceans, crabs, lobsters, and certain cool water and bottom feeding finfish and seaweed or kelp. The organic forms of arsenic found in seafood, mainly arsenobutane and arsenocholine, also referred to as fish arsenic, are generally considered to be non toxic and are excreted in urine within 48 hours of digestion. However, inorganic forms of arsenic has been found in some types of seaweed. Recent literature suggests that hickey seaweed has a variety of high levels of organic arsenic, inorganic arsenic MMA. So there is a picture of arsenic found in seaweed or seafood. Let's talk about its atomic structure. Two-dimensional black arsenic is a van der Waals layer material which has atomic structure and physiological properties analogous to one of the most prominent and well-studied 2D materials, black phosphorus. Here, an analytical stem is utilized to explore the nature of 2D layered BS, highlighting its layer-dependent dielectric responses and moisture-sensitive degradations at various ambient environments. The surface science techniques of low-energy electron diffraction, LEED, X-ray photoelectron spectroscopy (XPS) and scanning tunnel microscopy (STM) has been used to characterize the clean Si 112 surface and the influence of an AS monolayer on the properties and structure on the surface. So there is arsenic structure. You can see arsenic with OH, with chlorine, and with hydrogen. These three bonds arsenic form with different compounds. And there is also arsenic structure in detail. In arsenic atomic orbitals, there is three orbitals, S, P, D, and fourth is F. You can see arsenic is in periodic table. Distribution of electrons in arsenic atom. The distribution of electrons in the shells of an arsenic atom is as follows. The first shell, K shell, contains 2 electrons. Second shell, L, contains 8 electrons. The third shell contains 18 electrons. And the fourth shell, N shell, contains 5 electrons. Electronic configuration. The atomic number of arsenic is 33, as we discussed earlier. Therefore, the electronic configuration of arsenic can be represented as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p3. The outermost shell of arsenic contains 5 electrons, including 2 electrons in the 4s orbital and 3 electrons in the 4p orbital. These outermost electrons are the valence electrons of arsenic and are responsible for its chemical properties, including its ability to form chemical bond with other. Valency of arsenic. Arsenic has 5 valence electrons. These are the electrons located in the outermost shell of the atom, specifically in the 4s and 4p orbital of the end shell. The valence electrons of arsenic play a crucial role in its chemical properties, including its ability to form chemical bonds with other elements. The valency of arsenic can vary depending on the compound it forms. Oxidation state of arsenic. Arsenic can exhibit different oxidation states ranging from -3 to +5. In its +3 oxidation state, arsenic forms compounds such as AsH3 arsine and As2O3 arsenious oxide, while in its +3 oxidation state, it forms compounds such as AsF5 arsenic pentafluoride and As2O5 arsenic pentoxide. It is worth noting that arsenic can also exhibit other oxidation states such as +1, +2, +4 depending on the specific compound it forms. However, the most common valencies for arsenic are +3 and +5. Let's talk about properties of arsenic. Atomic properties. Chemical symbol for arsenic is As. Number of protons in arsenic is 33. Atomic number of arsenic is 74.921529 or gram per mole. Melting point of arsenic is 613 degrees Celsius and the boiling point is 613 sub Celsius. Physical properties. The physical properties of arsenic depend largely on how it is processed. Natural arsenic features a grey, silvery color and serves as a highly effective conducting material. It has a garlicy odor and it is chemically stable yet fairly brittle. When heated, arsenic's properties change as it's transformed into a liquid, then a gas. This gas is known as yellow arsenic, and when it cools and solidifies, it develops a soft waxy texture. Once yellow arsenic is exposed to light, it transforms into black arsenic. Black arsenic is considered a mineral and is completely non-metallic. One of the most well-known properties of arsenic is its toxicity. Then its physical properties. There is a table in which we discuss its physical properties. Sublimation point 887 K. Its density is 5.7 to 7 gram per centimeter cube. Liquid 5.22 gram per centimeter cube. Triple point 1. Let's talk about impacts and effects of arsenic. Inorganic arsenic compounds such as those found in water are highly toxic, while organic arsenic compounds such as found in seafood are less harmful to health. Arsenic is highly toxic and causes a range of health problems including skin lesions, cancer and cardiovascular disease. Exposure to arsenic can occur through contaminated food and water as well as through inhalation of airborne arsenic particles. Due to its toxicity, regulations have been put in place to limit exposure to arsenic in the workplace and the environment. Side effects in human health. Exposure to high levels of arsenic can cause cancers of the skin, bladder, kidney, and lung, and disease of the blood vessels of the legs and feet. Diabetes, high blood pressure, and reproductive disorders have also been linked to arsenic exposure. Even in its natural state, arsenic may cause accidental illness or death if it comes into contact with local water supplies. Once ingested or inhaled, this material competes with phosphates in the body during standard metabolic processes, which eventually leads to mass or organ failure. This is a picture of arsenic toxicity in human health. and cause diseases as gangrene, keratosis, spotted melanosis, hyperkeratosis. Arsenic, when induction of corticosterone, its direct inhibit sperm cells, Sertoli cells, Leydig cells, pituitary cells, and adrenal cells, and reduction of gonadotropins when affects in pituitary gland, and its directly affect uh, and enzymes in Leydig cells. Also, induction of apoptosis in Sertoli cells and inductions of apoptosis in sperm cells. Effects on plants. Arsenic is non-essential and generally toxic to plants. Plants absorb arsenic failure easily, so that highly ranking concentrations may be present in food. Roots are usually the first tissue to be exposed to arsenic, where the metallite inhibits root extension and proliferation. Upon translocation to the shoot, it can severely inhibit plant growth by slowing or arresting expansion and biomass accumulation, as well as compromising plant reproductive capacity through losses in fertility, yield, and fruit production. At sufficiently high concentrations, arsenic interferes. Effects on plants. Biological nitrogen fixation, including the contribution made by the symbiosis in the root nodules of legumes, supplies a large proportion of the N in biological systems and is generally sensitive to arsenic toxicity. Arsenic shows toxicity even at low exposure levels and causes black food disease. These are diseases in plants. You can see where leaves damage due to arsenic. Toxicity. Effects on water. Water is a major source of human exposure to arsenic compounds. Underground water and water aquifers are contaminated when arsenic-bearing minerals undergo oxidation and release arsenic into water. The reduction of FeAs oxides could also be a source of arsenic contamination in groundwater. Some regions across the world have been observed to have arsenic drinking water levels exceeding the standards set by the US Republic Health Service and the World Health Organizations. For US and Canada, and 50 microgram per liter for and developing countries with limited access to potable water and larger populations exposed to arsenic. Bangladesh and West Bengal, India are the most affected areas of the world with arsenic concentration in groundwater. In some areas, that is up to 3,200 microgram per liter. The inorganic form of arsenic is the most common species found in water and can be stable as both arsenide or trivalent and arsenate or pentavalent inorganic arsenicals. Arsenic 3 is the most prevalent species in groundwater, while arsenic 5 species are more significant in the surface water of rivers. Effects on animals. Birds eat the fish that already contain eminent amounts of arsenic and will die as a result of arsenic poisoning as the fish is decomposed in their bodies. The toxic dose of arsenic can vary greatly depending on the form of arsenic, the animal species, and the health status of the animal. Cats and humans are the most susceptible to animal poisoning. Weak, debilitated, and dehydrated animals are more susceptible than normal, healthy animals. Once absorbed by the body, arsenic travels to all the organs such as liver, spleen, kidneys, lungs, and gastrointestinal tract. Once there, it mainly affects the vascular system, blood vessels, leading to swelling and bleeding in the organs. There's eye disease in animals, you can see. Effects on fishes. The untreated and uncontrolled discharge of arsenic by industries into the natural water bodies poses serious threat to aquatic fauna by deteriorating water quality and making it suitable for fishes. Fish is an important bioindicator of aquatic bodies, and excessive organic or arsenic concentration causes its bioaccumulation in fish organs and muscles. This deposited arsenic in the fish imposes serious damage to physiology, biochemical disorders such as poisoning of gills, livers, decreased fertility, tissue damage, lions, and cell death. It also enters in the cell and produces reactive oxygen species, which increases the level of stress, which further concentrates the oxidative enzymes and cortisol levels in fish. The uncontrolled discharge of arsenic and its devastating impact on fish diversity is a major concern for aquaculture progress and economic stability. Here is a picture in which fish died due to arsenic poisoning. Arsenic impacts on fish health. It inhibits fish growth. It weakens the immune system of arsenic. It reduces fish rate. It damages cells and tissues of fish, induces oxidative stress and apoptosis. Here is a picture in which arsenic affects fish with an intestinal gut. Arsenic 5 and arsenic 3 mainly toxic to fish. Disadvantages of arsenic. Arsenic is a toxic element. There is evidence that its high dosage in the form of formulations have killed athletes. Inorganic arsenic is carcinogenic. We consume arsenic mostly from drinking water and agricultural products. High amounts of arsenic in the body causes arsenic poisoning, which may affect a broad range of organs and organ systems. It may affect skin, cardiovascular system, immune system, endocrine system, nervous system, and respiratory system, etc. Elemental arsenic and inorganic arsenic compounds are more poisonous than organic arsenic compounds. Acute and chronic arsenic poisoning. Let's discuss it. Acute effects. The immediate symptoms of acute arsenic poisoning include vomiting, abdominal pain, and diarrhea. These are followed by numbness and tingling of the extremities, muscle cramping, and death in extreme cases. Long-term effects. The first symptoms of long-term exposure to high levels of inorganic arsenic, for example through drinking water and food, are usually observed in the skin and include pigmentation changes, skin lesions, and hard patches on the palms and soles of the feet, which is hyperkeratosis. These occur after a minimum exposure of approximately 5 years and may be a precursor to skin cancer. Limitations of arsenic. Let's discuss it. Limitations of arsenic in water. As per BIS standards, the maximum permissible limit of arsenic in drinking water is 0.01 mg per liter ppm or 10 microgram per liter ppb. In order to illustrate the relative importance of exposure through consumption of food and drinking water, the contribution of dietary intake to human exposure to inorganic arsenic was estimated as 2 microgram per d. This estimate is based on the total dietary intake of arsenic of 40 microgram per d and 5% contribution of inorganic arsenic to the total dietary intake. This estimated value for dietary intake of arsenic, inorganic arsenic 2 gram per day is comparable to the exposure that would result from the consumption of 21 per day of drinking water containing 1 microgram per 1 inorganic arsenics. Limitations in rice. Arsenic concentration in rice grain range from 2.00 to 1200 to 60 microgram kg1 with a mean value of 146 microgram kg1 or 1 kilogram. The hazard quotient for intake of arsenic by human through consumption of rice varied from 0.03 to 3.52. HQ exceeds 1.0 for drinking water and rice grain grown in the study area in many cases. As high as 77.6% variation in arsenic content in rice grain could be explained by the solubility-free ion activity model. Toxic limit of extractable arsenic in soil for rice in relation to soil properties and human health hazard associated with consumption of rice grain by human was established. Toxic limit of extractable arsenic in soil for rice in relation to soil properties and human health hazard associated with consumption of rice grain by human was established. Besides, WHO has set standard for maximum permissible limit of arsenic concentration in rice as 1 milligram 1 kg, while it is 0.15 and 0.5 milligram 1 kg as prescribed by USDA and EU respectively. Limitations of arsenic in soil. For example, the permissible limit of Olsen extractable arsenic in soil would be 0.43 mg for 1 kg rice cultivation. If soil pH and organic carbon content were 7.5% and 0.50% respectively. However, the critical limit of Olsen extractable arsenic in soil would be 0.54 milligram for 1 kg if soil pH and organic carbon was 8.5% and 0.75% respectively. Action against high limits of arsenic. Let's discuss. Current approaches to risk assessment typically assume a linear dose response for mutagenic compounds that directly interact with DNA or when the carcinogenic mechanism is unknown. Because the mode of action of arsenic-induced carcinogenesis is not well established, recent dose response assessments for arsenic have assumed linearity at low doses despite evidence that arsenic is not direct acting mutagen. Several modes of action including generation of oxidative stress, perturbation of DNA methylation patterns, inhibition of DNA repair, and modulation of signal transduction pathways have been proposed to characterize arsenic's toxicity. Preventions and control. The most important action in infected communities is the prevention of further exposure to arsenic by the provision of a safe water supply for drinking food. And irrigation of food crops. There are a number of options to reduce levels of arsenic in drinking water. Substitute high arsenic sources such as groundwater with low arsenic, microbiologically safe sources such as rainwater and treated surface water. Low arsenic water can also be used for drinking, cooking, and irrigation purposes. Various high arsenic water can also be used for other purposes such as bathing and washing clothes. And discriminate between high arsenic and low arsenic sources. For example, test water for arsenic levels and paint tube wells or hand pumps different colors. This can be an effective and low cost means to rapidly reduce exposure to arsenic when accompanied by effective education. Blend low arsenic water with high arsenic water to achieve an acceptable arsenic concentration level. Long term actions are also required to reduce occupational exposure from industrial processes. Install arsenic removal systems, either centralized or domestic, and ensure that appropriate disposal of the removed arsenic. Technologies for arsenic removal include oxidation, coagulation, precipitation, absorption, ion exchangeable, and membrane techniques. There is an increasing number of effective and low cost options for removing arsenic from small or household supplies, though there is still limited evidence about the extent to which such systems are used effectively over sustained periods of time. Education and community engagement are key factors for ensuring successful interventions. There is a need for community members to understand the risks of high arsenic exposure and the sources of arsenic exposure, including the intake of arsenic by crops, for example, rice, from the irrigation water, and the intake of arsenic into food from cooking water. Uh, Diagnosis. Pathological testing can confirm an instance of arsenic poisoning. And in areas and occupations with the risk of arsenic poisoning, it is important to monitor the levels of arsenic in the people at risk. This can be accessed through blood, hair, urine, and fingernail samples. Urine tests should be carried out within 1 to 2 days of the initial exposure for an accurate measure of when the poisoning occurred. These tests can also be used to help diagnose cases of apparent arsenic poisoning. Tests on hair and fingernails can determine the level of arsenic exposure over a period of up to 12 months. These tests can give an accurate indication of arsenic exposure levels, but they do not show what effects they may have on the person's health. So, from this, we can easily diagnose arsenic exposure. What is the remedy or treatment of arsenic? Let's discuss it. Chelating agents administered within hours of arsenic absorption may successfully prevent the full effects of arsenic toxicity. Carpal 2,3 dimer captopropanol, also known as British and Leviside RBL, for previously the most frequently recommended chelating agent for arsenic. Ball irrigation is another option. Special solution is passed to the gastrointestinal tract, flushing out the contents. The irrigation removes traces of arsenic and prevents it from being absorbed into the gut. Vegetables containing organosulfur compounds are useful in clearing arsenic from the liver. An organosulfur natural compound dial sulfide found in garlic, allium sativum, has been shown decreasingly and arsenic induced mitochondrial toxicity in rats. Treatment methods also include removing cloths that could be contaminated with arsenic, thoroughly washing and rinsing affected skin, blood transfusions, taking heart medication in case where the heart starts failing, using mineral supplements that lower the risk of potentially fatal heart and rhythm problems, observing kidney functions. So guys, let's conclude our today's topic. Water supplies generally contain negligible quantities of arsenic, although some cases of endemically poisoned waters have been reported. Industrial effluents have been shown to contain arsenic, but the self-purifying tendency of rivers and streams and improved quality of water wastewater discharge should help to minimize this problem. This continued concern about the association between inorganic arsenic and cancer has raised questions regarding the implications of widespread dispersion of inorganic arsenicals in the environment. Clearly, the ecological uncertainties about arsenic compounds deserve more effort and attention. Thank you so much for watching my today's presentation. Take care. Allah Hafiz.